So join me back on the steep learning curve that is learning how to use my tablet and the new version of OneNote. So I still want to talk some more about section 3.3, the binomial expansion. And I want to re-say what I said at the end of the last video, that 0 factorial is defined as 1. So that makes all the rules work properly. You're never dividing by 0 in any instance. So now what I want to look at is, say, for this element in the triangle, I want to look at what happens when the exponent is 3 and I say 3 choose 0. So that's going to be 3 factorial over 0 factorial over 3 minus 0 factorial. Well, that's going to be 1. And what do you know? That's the first entry in that row. So now let me do 3 choose 1. 3 factorial over 1 factorial over 3 minus 1 factorial. So I'll let you compute that and think about it, but that's going to give you the 3 that is the next entry in the Pascal's triangle. And then if you do 3 choose 2, you're going to get 3 factorial over 2 factorial over 3 minus 2 factorial, and you're going to again get 3. And then if you do 3 choose 3, if you think about it and you have 3 things, there's only one way to pick 3 things, and so that is the 4th entry in the Pascal's triangle. So when the exponent is 4, this row is 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. You can verify that. So now I want to look at, what about this? Let's look at this bottom row that we were working on to notice how it became the coefficients. Well, I want you to notice that 4 choose 0, oops, sorry, 5 choose 0, because I'm on the row where the exponent is 5. Notice that this 5 corresponds to the exponent on the first term. And then this 5 comes from 5 choose 1. And notice also that the exponents on the x and the y always add up to 5. Then this next coefficient is 5 choose 2. And again, the exponents always add up to the 5. And then also notice that this 2 matches the exponent on the second guy. So there's a lot of patterns going on here, so just be really aware and noticing patterns. So this next coefficient is 5 choose 3. So again, notice that the 3 corresponds to the exponent on the second guy, and that the 2 exponents together always are adding up to the 5. And then we have 5 choose 2. Whoops, 5 choose 1, 2, 3. This is 5 choose 4, and 5 choose 5. Okay, so that's the idea of the binomial theorem, is it can really speed up expanding something like this guy of x plus 2y to the 6th. So I want to first do the whole expansion, and then let's talk about how do you just find one term that's being asked for. So let me back up a little here, because we're going to just first use the binomial theorem to expand a binomial. Okay, so here we have an x as the first guy and a 4 as the second guy. And our power is 3, so we're going to write 3 choose 0, 3 choose 0. Then the first guy is going to be to the power of 3, and the 4 is going to be to the power of 0. Plus 3 choose 1. Then the x is going to be to the power of 2, and the 4 is going to be to the power of 1. plus 3 choose 2. The x is going to be to the power of 1, and the 4 is to the power of 2. Then 3 choose 3, and the x is to the power of 0, and the 4 is to the power of 3. So we need to simplify this so it looks like a normal polynomial. So let's do that. 3 choose 0 is going to be 1. Then we have x cubed, and 4 to the 0 is 1. Then 3 choose 1 is 3. And then we have times a 4, and then an x squared. So in the next step, I'm going to combine those two. You could do that in one step if you like, but I try and do things slowly, step by step, especially when I'm learning something new. So then in the next term, I have 3 times a 16. Here's my 16. And an x. Plus 3 choose 3 is 1. X to the 0 is 1. And 4 cubed is going to be 64. So my final answer is going to be x cubed plus 12x squared plus 48x plus 64. And when it's only to the power of 3, you probably could do it by hand just about as fast. But what if the power was 12? Wow, I'd really way rather do it this powerful way, where we save a lot of work for ourselves. So now let me look at one more that has a negative in it to make sure we've done an example like that. And this is to the power of 4. So I know I'm going to have 4 choose 0. And then the 2x to the 5th power is going to be to the power of the 4. And the negative 1 is going to be to the power of 0. Plus, then I have 4 choose 1, and the 2x to the 5th is going to be to the power of 3, and the negative 1 to the power of 1. So you can see that this is going to come out to be a negative term. Plus 4 choose 2, and the 2x to the 5th squared times the negative 1 squared, plus 4 choose 3, and 2x to the 5th to the power of 1, and negative 1 to the power of 3. And one more term, 4 choose 4. Now the 2x to the 5th is to the power of 0, and the negative 1 is to the power of 4. Okay, so we've already done this expansion with the Pascal's triangle, so we know these coefficients. So 4 choose 0 is 1, but then I'm going to have 2 to the power of 4 times x to the 5th to the power of 4. And so that's going to need a little more simplifying. Plus, then I have a 4, then I have a 2 cubed, and an x to the 5th cubed, and then I have a negative 1. Okay, then the next 4 choose 2 is 6, and I'll have 2 squared times x to the 5th squared, and then negative 1 squared is just a 1. Plus 4 choose 3 is 4, and then I have 2x to the 5th, then I'll have a negative 1, plus 4 choose 4 is 1, 2x to the 5th is 1, and negative 1 to the 4th is 1. So that's just going to be plus a 1 at the end. Okay, so let's write our final answer. 2 to the power of 4 is 16, and then x to the 20th. 2 to the 3 is 8 times 4 is 32, and this is a negative 32, x to the 15th, plus 2 times 2 is 4 times the 6 is 24x to the 10th minus 8x to the 5th plus 1. So this is your final answer to expand the binomial. So this was letter C. Okay, so then the last thing I want to look at is how do we find a particular term if we're asked for a particular term? That's when you need to look at all these patterns. So if you're to the power of 6, you know you're always going to be 6 choose something. Well, notice that the third term has choose 0, 1, 2. This is the choose how many for the third term because we started at 0. So you have to be really careful and think hard about that. So then you had x to the 6, 5, 4. So you're going to have x to the 4. And then the 2y needs to be to the power of 2 because those two exponents always have to add up to 6. Or you could think of the 2y as being to the power of 0, then 1, then 2. Okay, so 6 choose 2. Let's see, that's our purple line up here above. No, that's one more down, 1, 6, 15. So this must be 15 times x to the 4th times 4y squared. So that's going to be 60 x to the 4th y squared. So these are kind of like puzzles. Okay, so let's do B here. And we want the 5th term, and the power is 10. So it's 10 choose, and then the 5th term is 0, 1, 2, 3, 4. Choose 4. So you have to remember to start counting with 0. And then we're going to have x to the power of, if it's the 5th term, it's 10, 9, 8, 7, 6. And then the -1 is going to be to the power of 4 because the exponents always have to add up to the 10. But you could always also notice that it always matches this, how many are you choosing? So let's see, 10 choose 4. I'm going to have to ask my calculator that. So I'm going to look at my button on my calculator. And I'm getting 210, so you could double check me on that. 210, and then x to the 6th, and then -1 to the 4th turns out positive. So let's go check down here on 3b. Sure enough, 210 x to the 6th. Okay, and let's do one more. And we have x cubed plus y squared to the power of 8. So it's 8 choose, then the 6th term, 0, 1, 2, 3, 4, 5. So it's going to be choose 5. Then the x cubed is the power of 8, 7, 6, 5, 4, 3. And the y squared must be to the power of the 5. And because the exponents need to add up to 8. Okay, so let's see what 8 choose 5 is. I'm getting 56. Then it's x to the 9th, y to the 10th. So make sure and ask if you have questions about this. This is important concept and topic, so I want to make sure that you're clear about it.